All right. Uh, so probably in seventh grade, you've heard this word before. I might have mentioned it once last year. Maybe, I don't know. Complementary angles. Anybody know what those are? Are two angles that add up to 90. So in the picture, if this was a 90-degree angle, then angle 1 and angle 2 would be complementary angles. So two angles that add up to 90 degrees. It could look like that. They don't necessarily have to be touching. It could look something like this is 30 degrees, this is 60 degrees. These are still complementary angles. They don't have to be adjacent to each other. They just have to add up to 90. You could say angle 1 is a complement to angle 2, or angle 1 and 2 are complementary angles, something like that. Adds up to 90. So if that is true, guess what we know about supplementary angles?
Adds up to 180.
Yeah, good guess. Adds up to 180. Two angles that add to 180 are supplementary angles. So these are definitions I'm giving you. So in a picture, they could look like a linear pair, like angle 1 plus angle 2 equals 180. But do they have to look like a linear pair? No. Like if this were 80, yeah, and this were 100, these would be supplementary angles because they would add up to 180. Okay. If they're a linear pair, they are definitely supplementary angles because they have to add up to 180. I feel like I'm forgetting something here, but I don't remember what it was. Hopefully it wasn't important. Okay. Oh, well, this is not it, but I just remembered I need to remind. Okay. Back in chapter 1, I think I mentioned this once, but it's going to be used quite a bit on this lesson. If you have a point, D or whatever, that's interior to angle ABC, then guess what I can say about this picture? Measure of angle ABD plus the measure of angle DBC. What do you think that's going to equal? Right, equals the big angle. So when you have two adjacent angles, the little angles add up to the big angle, right? So that's kind of a does statement because it seems like it should just be true. This little angle plus this little angle equals the big angle. And that's called angle addition postulate. Remember that postulate just means something that's kind of basic and then we just assume is true. You don't prove it, you just assume it. So angle addition postulate, that's kind of an important one. That was from chapter 1, so it's not really in this part of the book. There are so many little theorems they threw in here, but I'll just mention one more. If we have a couple congruent angles, let's say these are both like 50 or something, and let's say this angle is a supplement to that angle, or complement to that angle, and this angle is a complement to that angle. What would this angle have to be if it's a complement to that angle? 40. And what would this angle have to be if it's a complement to that angle? 40. So one of the theorems, there's no name for it, is complements of congruent angles are congruent. Does that make sense? Complements of congruent angles are themselves congruent. These two angles are equal, their complements have to be equal. Or supplements of congruent angles are congruent. What's the supplement to 50 degrees? 130, it adds up to 180. So supplements of congruent angles are congruent. statement, but it is a theorem, even though it's, because you can prove it. Oh yeah, I was gonna say on these vertical angles, that's basically what's happening. 1 is supplementary to angle 4, 3 is supplementary to angle 4, so 1 and 3 are congruent. Because they're supplements of the same angle. Anyway, somewhere. Alright, I think we've sorted it out. Oh, here's a question. If I have two congruent supplementary angles, what does each angle have to be? If I have two supplementary angles that are congruent, what does each of them have to be? 90. 90 plus 90 is 180, right? Congruent means they have to be the same. So if the two angles are the same that add up to 180, they'd have to both be right angles. That's a theorem. There's no name for these theorems. You just say them whenever you want to, like congruent supplementary angles are right angles. If I had two congruent angles that are complementary, what would each of those angles have to be? Two congruent angles that add up to 90, what would each of them have to be? Half of 90, right? 45. Make sense? Those are theorems, but there's no name for these little theorems. They're not as useful, and sometimes you have to state them in your argument. So the two, I'll say the three important things from this are linear pair theorem, that if it makes a straight line, they add up to 180. Vertical angles are congruent to each other. And what was the other one? Oh, angle addition, postulate. That's the important, most important things. Okay, page 92. Here we go. Says, number 1, what kind of angles are angle GKJ and angle HKI? So that top and that bottom angle are what kind of angles?
Congruent or obtuse.
Okay, what's the word we learned today, though? No?
Oh no.
Going back in time. Remember? 1 and 3 vertical angles, yes. They are obtuse, they are congruent, but that's not what they're looking for. They're looking for what we learned today. Vertical angles. Okay, number 3. Find the measure of angle IKH. So if you look in that picture, they tell us that angle IKJ is 55 degrees. So how can we find that angle at the bottom?
We subtract 55 from 180.
Okay, these two angles together, this one and this one, make a straight line. They make a straight angle. So they are a linear pair. They have to add up to 180. So yeah, if you do 180 minus 55, that would give you the missing angle, 125. Okay. Oh, by the way, I remembered one thing I meant to say. So there's complementary and supplementary angles, right? Those two are in alphabetical order because complementary C comes before supplementary S, and 90 comes before 180. So that can help you remember. Complementary, supplementary, and alphabetical order. Number 5, what is the measure of the complement of angle JKI? So what is the complement
Adds up to 90.
of 55 degrees?
35.
90 minus 55, yeah, 35 degrees. What is the supplement of 55 degrees?
125.
180 minus 55, 125. So complement means they have to add up to 90. Supplement means they add up to 180. Number 6. 7, name two angles that are supplements. This one's a kind of a tricky one. Of angle FGE. Do you guys see angle FGE in the picture?
Yeah.
How many degrees would that angle have to be?
So it would be 50.
50. You see the vertical angle on the right, angle BGC is 50 degrees, so angle FGE is 50. That's not what they asked us though. They asked us what angle is supplementary to angle FGE. In other words, that angle plus what other angle would add up to 180? Yes, EGC. So another way to think about it is what other angle with angle FGE makes a straight line, a linear pair. So if you look below line FC, FGE and EGC make a straight line. So angle EGC would be supplementary, and we need another one. They asked for 2. Okay, yeah. Above line EB, we have angle FGE and FGB. Those two make a straight line together. You guys see what I'm looking at? Hopefully. If not, you might go back and look at the answer and compare it. Yeah, we got it. Okay, number 9 says find the measure of angle FGE, which we already talked about, 50 degrees. Because it's a vertical angle with that other 50-degree angle. Number 11 says find the measure of angle BGD. Yeah, when you have 190-degree angle and it's in a linear pair, what's the angle right next to it have to be? 90, because 90 and 90 make 180, right? Okay, yeah, if one of these is 90, the other one right next to it has to be 90. That makes a straight line. Number 13. All right. On number 12 it says classify each angle by its measure. What do you think they mean by that?
Like obtuse or acute?
Yeah, obtuse, acute, right, straight, those things. That's what they mean when they say classify the angle. Okay, on 13, write a statement illustrating the property. Reflexive property of congruent angles. Does reflexive ring any bells for you guys? What?
Well, the reflexive property was like A equals A.
Exactly. It was page 79. Remember that from yesterday? 79, it said reflexive property A equals A. So how could we do that with congruent angles?
Like 90 degrees is congruent to 90 degrees.
More like angle A congruent to angle A. Angle is congruent to itself. Mind blowing. Number 15. Transitive property. What was the transitive property?
If A equals B and B equals C, then A equals C.
Right. If A equals B and B equals C, then A equals C. So how can we do that with angles? If angle A is congruent to angle B, and what else? Angle B is congruent to angle C, then what do we know?
Angle A is congruent.
Angle A is congruent to angle C. So kind of just replaced A, B, and C with angle A, angle B, and angle C. All right. Number 17. Name the definition, postulate, or theorem that justifies the statement. So on 17, it says if angle C and angle D are supplementary, an angle, the measure of angle C plus the measure of angle D equals 180. How did they know those two would add up to 180? Because it said that's what supplementary means. So what's the reason we're using? Definition of supplementary. They knew those two angles added up to 180 because that's what supplementary means. So they're using the definition of supplementary. Number 9, if angle X and angle Y form a linear pair, then angle X and angle Y are supplementary. So linear pairs, the angles add up to 180. You guys remember what I said that was called? I'm not going to scroll back up and look at it. Linear pair theorem. Let's look at 20. It says if C is a point in the interior of angle ABD. So let me draw that. Here's angle ABD. C is somewhere in the interior. So then it says angle ABC plus angle CBD equals angle ABD. What did I say that was called? No. This angle plus this angle equals big angle. Angle. Addition postulate. Little angle plus little angle equals the big angle together. Angle addition postulate. What the heck are the seniors doing? Alright, for all those who have been missing algebra, this is for you.
Yeah. Amazing.
Okay, so on 21 it says we're supposed to find x. So how could I find x in that picture? What do I know about those two angles they gave us? They're equal because they are vertical angles, right? Vertical angles are always the same. Yeah, they're congruent. So what equation am I going to set up to solve for x?
13x equals 7x plus 6.
Whoops. All right. Yeah, go ahead and show your work. Now what? Distribute. What? Now what? If we have x's on both sides, right, get rid of them on one side.
Shut your mouth.
So polite. Shut your face and never
Wow.
talk again.
X
Thank you very
equals
much.
7. Amazing.
Please and thank you.
And then you're just like putting in the.
Okay, that was the A question.
Yeah.
The B question is, what's the measure of angle AED, the bottom angle? How could I figure that one out? Yeah, we just figured out x was 7, so if we put it in down there,
91.
what is 7 plus 6 times 7?
Now do the.
7 plus 6 is 13, times 7, 91.
Yeah.
Okay, then question C says find the measure of angle CED. That'd be the right angle. How could I, they didn't label that one. How could we find the right angle? Somebody besides Grant and Shelby. How could we find the right angle? Am I forced?
Subtract from 180.
Yes, subtract from 180. Those two angles below line AC are a linear pair. They have to add up to 180. So if we do 180 minus 91,
89.
we get that missing angle.
You know that one Cool Kid song that was the entertainment? That was made in 1902.
Okay. 23. What do we know about those two angles on 23? They add up to 90. So how would I write that as an equation? You try?
4z plus 70z plus 2 equals 90.
That plus that equals 90. It's not a trick question. So how could we simplify that?
11z plus 2 equals 90.
Add like terms.
Or it can be like 11z equals 88.
We got 15 times. What do you get?
And that'd be like 8 equals z. It is math. And then it'd be 32 and like the other one was 68. Math stuff.
You're a little bit off. Okay, on B it says we're supposed to find angle GHJ, the top one. So how could we do that? 4 times 8, 4 times Z, 32. And on C, it's asking for angle GHK, or JHK, the bottom angle.
68.
So you could plug in the Z value of 8 and figure it out, but also we know they should add up to 90. So 90 minus 32 is not 68.
Oh, dang, man. Oh, yeah. I wrote down 50.
It's like 77 plus 33.
Yeah.
It's not equal 1, equals 110.
I even wrote down 58, but I just said 60.
Sure you did, Grant. It's okay.
That's just what I say.
Yeah, on this page, it actually is on this one, it isn't. I'm done.
15 times.
Yeah. Yeah. No, wait, no, we don't. We have 38, 30 plus 2.
It's 32.
Okay,
39.
number 25, supply the missing, we did a few of these yesterday. If angle 1 is congruent to angle 2, and angle 2 is congruent to angle 3, then what do we know by the transitive property? Alright, angle 1 is congruent to angle 3. We're almost there, people. We're getting close.
Yeah! That
If-
was not needed.
Number 27, it says W is a point in the interior of angle XYZ. Then what do we know by the angle addition postulate?
It's like W by ZX.
Angle edit. Plus, keep going. Yep, that's it.
Yay! I love math.
I don't.
Math make me sad.
When the book is talking about the angle measurements, they always put a little M in there. Sometimes I skip them just because it takes longer, but yeah. The M is to represent the measurement, like the number, as opposed to just the angle itself. '29. Okay, on 29, the first line is blank. The second line says their conclusion is angle A and angle B are supplementary by the definition of supplementary. So how could they have known that the angles were supplementary if they knew what?
A plus B plus 180.
Right, if they knew that angle A plus angle B equals 180. So yeah, like I said, I'm skipping the M's on this one. Obvious what I mean, so I'm not gonna worry about it. Okay, did I? Okay, with the other class, I actually didn't do 39 with them because it was taking too long. I only did 38. So, probably same thing with you guys. 38 is a proof. It says given angle 1 is equal to angle 3. But it's not a fill in the blank proof like we did yesterday. It's make your own from scratch proof. So, do you guys remember what goes at the top of the proof?
The give and get.
Well, that's line 1, but what goes above line 1?
The number.
Statement and reason, yeah. There's line 1 statement and line 1 reason for that statement. Let me see, do I draw the picture wrong a little bit? Okay, before we get going here, let's kind of look at this for a second. The given part is that angle 1, this one, is congruent to angle 3. Okay, they're telling us that. What we're trying to get to, what we're trying to prove, is angle AXD, this angle, is congruent to angle, or equal to angle BXY, this angle. So if angle 1 and angle 3 are equal, why does that mean these two medium-sized angles would have to be equal? I'm trying to make a plan to figure out how I can show that is true. Okay, this angle up here, this first top medium-sized angle, is made up of angle 1 plus angle 2, right? This lower medium-sized angle is made up of angle 3 plus angle 2. So if 1 and 3 are the same, and you add 2 to both of them, they'll still be the same. Does that make sense? They told us 1 and 3 are the same. That was the given. That's going to be our first line. If I add 2 to angle 1, I get this angle right here. If I add angle 2 to angle 3, I get this angle down here. We're supposed to show that those red things, those red angles are congruent. I know they're congruent because if you add an equal value to 1 and 3, and 1 and 3 are equal, they should still be equal. So that's kind of my plan. All right, what goes on the first line always? The given. What was given to us? Angle 1 equals angle 3. The reason I know that is given. Okay, this next one, I don't have the answers in front of me, but actually I might. Yeah. This next line I might have skipped if I was doing it myself, but I'm going to go ahead and write it just to kind of show you what they're thinking on this. Whoops. Forgot the angle somewhere. Does anybody remember what that was called? Something is equal to itself? Briefly. reflexive, yeah. Ding, 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 you got it. It's one of those things from page 79. Okay, why the heck would we write that in the first place? Well, the reason they wrote it, and like I said, I would probably skip that line because it's not absolutely necessary. Because the next line is what they're trying to get to here. Okay, yep. Yeah. What did we do to get to line 3? What happened? Added angle 2 to both of those. Right? So this is kind of why this was written in the first place. What's it called when you add the same value to both sides of an equation? Addition property of equality. Because it's a trick you can use on equations. Addition property of,
At the end, there's a room more.
no, we're done when we get to the line we're trying to prove.
Oh, no.
How many lines is that?
5. On this one, so coming up here, I just said angle 1 plus angle 2 equals 3 plus 2. What does angle 1 plus angle 2 also equal to?
Two plus three.
Well, that's kind of what I just said, but what else is it equal to besides 2 plus 3? Right, it's equal to the big angle, the medium sized or whatever. It's equal to this angle right here, right? And we're trying to show those medium angles are congruent. So I'm gonna say angle 1 plus angle 2 equals, what was it called, AXD? Yeah, AXD. That's the next line. This thing right here is equal to AXD. This thing right here is equal to BXY. So that's what I'm gonna say in my next line. Measure of angle 1 plus measure of angle 2. Forgot already, AXD. That was fast. All right. How did I know that was true? How do I know that little angle plus little angle equals big angle? Angle addition postulate, yes. Okay, last one, almost there, almost done. Well, what does the last line always end with? Or what I was trying to prove. Which they tell us what we're trying to prove, so you can kind of copy that down. But measure of angle AXD equals measure of angle BXY. Alright, but how did we get there? That's the question. You guys might not realize we have arrived. Okay. This thing is equal to angle 1 plus 2. This thing is equal to angle 3 plus 2. So I can replace angle 1 plus 2 with this, and 3 plus 2 with that. Substitution, yes. Probably the most used trick in proofs. Huh? Oh, I said, yeah, we don't have enough time for that. So, yeah, don't worry about 39, just try the evens.